Cotter joint. In previous two videos, we have seen about the design procedure and numerical on the basis of knuckle joint and turnbuckle. And similarly, Cotter joint is also one type of mechanical joint, which is also widely used in an industry and as well as various particular applications, specific applications. So let us see what doing the Cotter joint is. So first of all, we should try to understand about what it is actually. A quarter is a flat wedge-shaped piece of rectangular cross-section and its width is tapered. See guys, what do you know quarter is? A quarter is a flat wedge-shaped piece of rectangular cross-section and its width is tapered. So quarter is a rectangular piece of cross-section and its width is tapered. Now how its width is tapered? Either on one side or both sides. So its width is tapered on one side or from both the sides, from one end to another for an easy adjustment. So this is about the cotter joint. That is, a cotter is a flat wedge-shaped piece of rectangular cross section. Its width is tapered, which is from one side or from both sides. It can be tapered, and this is why it is made so, for easy adjustment. Okay. Now what it is written in second point, please see. The tapered varies from 1 in 48 to 1 in 24, and it may be increased up to 1 in 8 if a locking device is provided. Then the locking device may be a taper pin or a set screw used on lower end of the cotter. The cotter is usually made of mild steel or wrought iron. See guys, the cotter is usually made of mild steel or wrought iron. Then a cotter is a temporary fastening and is used to connect rigidly to coaxial rods or bars which are subjected to axial tensile or compressive forces. So see guys, this last point is telling about the function and application of cotter joint, that where it is used and for what purpose we are using cotter joint. Please focus your attention over here. A cotter joint is a temporary fastening and is used to connect rigidly. What it used to connect? It used to connect rigidly two coaxial rods or bars. See guys, coaxial two coaxial rods or bars which are subjected to axial tensile or compressive forces. So why we are using cotter joint? We are using cotter joint to connect two coaxial rods. See guys, two coaxial, the axis of two rods which are going to be connected by using cotter joint, that should be in one axis or coaxial, which are subjected to axial tensile or compressive forces. So let us see what next. Now what are the various applications of cotter joint? Please see guys, in this slide we are get to see the applications of cotter joint, what it is. First of all, I would like to take you about the constructional features of cotter joint, what it is. So this is a cotter joint that you are seeing. This portion is called spigot. It is written over here. This portion is called socket, and this is, you can see, this is what cotter. As we have seen, it is a rectangular piece, okay, and its width is tapered from one end or both ends. Okay, so this is what it is actually. And what are the applications of cotter joint? Please see guys, it is usually used in connecting a piston rod to the cross head of a reciprocating steam engine. See guys, why it is used? It is usually used in connecting a piston rod to the cross head of a reciprocating steam engine. Then a piston rod and its extension as a tail or pump rod. Next is strap end of connecting rod. These are the three main basic applications of cotter joint where this joint is used widely. Then what it is next? Please see. Now see, there are some practical application images of cotter joint that we are seeing. See guys, this is the practical application images of cotter joint. This is the in railway steam engine that you are seeing. This is cotter pin. Okay, in this image you can see, if you see my pointer, in this image this cotter joint is, we are getting to see very clearly, and these are the various practical applications of cotter joint. Now let us see what are the various types of cotter joints. If you are seeing this, then what are the various types of cotter joints are? Please see. Following are the commonly used cotter joints to connect two rods by a cotter. See guys. First rod is socket and spigot cotter joint. What? First very popularly used cotter joint is socket and spigot cotter joint that we have seen in an image in application part. Second one is sleeve and cotter joint. Second one is what? Sleeve and cotter joint. Third one is jib and cotter joint. So these are the three basic types of cotter joint. That is, first one is socket and spigot cotter joint. Second one is sleeve and cotter joint, and third one is jib and cotter joint. Okay. So the design of these types of joints are discussed in detail in the following stages. So we are going to see the design of all these three types of quarter joints. So without wasting time, let us start. Now, as you are seeing in this slide, in this image, you are getting to see a orthographic view of quarter joint. Okay, that is front view and top view of side view of quarter joint that you are getting to see here. In by this video, by this image, we can you know uh, we can be very familiar about the quarter joint constructional features. Okay, how it is constructed and what are the various parts of socket and spigot quarter joint. See, so what it is written here, design of socket and spigot quarter joint. See guys, so this uh, diagram that you are seeing, it is for socket and spigot quarter joint. This is the type of quarter joint which name is socket and spigot quarter joint. So see, first of all, we should uh, study about the various parts of socket and spigot quarter joint. So socket, why it is called as socket and spigot quarter joint? Please see, this part of this part of this joint is called socket. Please see guys, this part of quarter joint is called as socket, and here you can see this part is called as spigot. As we have seen 3D image in application part, this part is called as spigot, and this is what quarter, which is, you can see here, you can observe this pin here, which is tapered, okay, from one side. Okay, this is one end and this is another end. So you can see from top to bottom, from this is top end and this is bottom end, and you can see easily this top to bottom there is a tapered portion is there. You get to see that this pin is made tapered. Okay, now this is quarter. Now what are the various dimensions, possible dimensions are here. Please see, this clearance is provided in between socket and your quarter. Please see, clearance is provided of 2 to 3 mm, and rest of the dimensions are written over here. These are the loads, that is P is a tensile load. Okay, you can see which is your joint is subjected to tensile load. Okay, and this is quarter, which are inserted to connect spigot and socket. Okay, and we are going to see all these dimensions, that is d1, what do you mean by d1, d, a, e, okay, small a, then t1, then c, d2, d3, okay, b, what do you mean by a, all these, d4, all these dimensions we are going to see in detail. So let me again revise you. This is the spigot part. Okay, this is the socket of your socket and spigot quarter joint, and this is quarter. This quarter is inserted in between the socket and spigot to connect it, and these are the two axial loads. To, you can see these rods, that is this is the rod, and these rods have same axis, that is they are coaxial rods, and to connect this coaxial rod we are using this quarter. Okay, so see, let us see what are the various uh, notifications and notations of quarter joint. Now see, now in this, now what we study about this and what we get to understand by this diagram, let us see. In a socket and spigot quarter joint, one end of the rods, that is say A, is provided with a socket type of ends as shown in figure. So just we have seen in previous slide, that is what, in a socket and spigot quarter joint, one end of the rods, say A, we can say A to one of the end of socket and spigot quarter joint, is provided with socket type of end. What socket type of end? The second point is the other end of the rod, say B, is inserted into the socket. See guys, one end is provided with the socket type end, and the other end, we are saying it B, is inserted into a socket. Okay, the end of the rod which goes into a socket is called spigot. See guys, the end of the rod which goes into a socket is called a spigot. So the end which is goes into the socket, that end is called spigot. Then a rectangular hole is made in the socket and spigot. See guys, a rectangular hole is made in the socket and spigot for easy insertion of quarter. Then a quarter is then driven tightly through a hole in order to make the temporary connection between the two rods. See guys, I have just told you earlier, a quarter is then driven tightly, driven means inserted tightly through hole which is rectangular in nature, in order to make the temporary connection between the two rods. Then after, the load is usually acting axially, but it changes its direction, and hence the quarter joint must be designed to carry both the tensile and compressive load. The compressive load is taken up by the collar on the spigot. So see guys, whatever is the we have seen in the diagram just written over here. Okay. Now these are the various notations. I have told you about the notations. These are the various notations which is used for the design of socket and spigot quarter joint. So you can see the heading that this design procedure of socket and spigot quarter joint, and you are seeing the notations in on this slide. Please see what are the various meaning of various notations, because this is very these all notations plays very important role in designing of various mechanical joints. Okay, as we have seen in knuckle joint, turnbuckle. Similarly, there are so many notations in case of socket and spigot quarter joint. Now let us see what meaning they have. Okay, so P is nothing but the load carried by the rods. Small d denotes diameter of the rods. Small d1 denotes outside diameter of socket. Small d2 denotes diameter of spigot or inside diameter of socket. D3 denotes outside diameter of spigot collar. D1 denotes thickness of spigot collar. D4 denotes diameter of socket collar. Then C denotes thickness of socket collar. B denotes mean width of quarter. Small t, it denotes thickness of quarter. So see, don't get confused over here. So T1 means thickness of spigot collar and small t is equals to thickness of quarter. Then small l denotes length of quarter. Small a denotes distance from the end of the slot to the end of rod. And now all these three stresses that we are going to analyze for are the same showing meaning, that is sigma t is equals to permissible tensile stress for the rod's material. Sigma tau is equals to permissible shear stress for the quarter material, and sigma c is equals to permissible crushing stress for the quarter material. See guys, sigma t means permissible tensile stress for rods material. See here rods is mentioned over here for rods material. Tau is showing permissible shear stress for quarter material, not rod, quarter material. And your sigma c also showing permissible crushing stress for quarter material. Okay, so don't get confused over here. Sigma t is showing tensile stress for the rods. Tau showing the tensile shear stress for quarter material, and sigma c showing crushing stress for quarter material. Okay, so this is all about the theoretical part of design of spigot and quarter joint. Thank you.